Hello, thank you for coming to my concert. Let's get back to it now, though.
Before we continue, let's see how exactly he caused that backflip to happen. It all started in the brain, the motor cortex to be exact, and from there an action potential travels down a neuron. When it arrives, a large quantity of calcium ions wait outside the cell while it connects to the synaptic cleft. The action potential makes the calcium enter the neuron by diffusion through voltage-gated calcium channels. It connects with the synaptic vesicles, causing them to travel down. The synaptic vesicles travel down to the bottom of the neuron, where the membranes fuse and acetylcholine is released and it goes into the synaptic cleft. An influx of sodium ions, which are now in the cleft and spread along the outside of the cell, begins to rush in once acetylcholine connects to receptors. The sodium travels down to the cell to the T tubules. The positively charged sodium makes the positively charged calcium go into the sarcomere. The sarcomere is where contraction actually happens.
That brings us to the inside of the sarcomere. Inside the sarcomere, there is a line of actin, a myosin filament, and then an actin. The actin is made up of troponin and tropomyosin. Whenever calcium comes from the sarcoplasmic reticulum, it attaches to one of the receptors on the actin, causing it to rotate towards the myosin. Meanwhile, ATP energy comes and connects to the myosin head. It then hydrolyzes into ADP, and the myosin head can go ahead and connect to a receptor and pull the actin in closer to a middle area. After that, it disconnects and returns to the area. The ATP comes and continues this process over and over again till it no longer needs to contract. This brings us to our next point, relaxation. Whenever you go to relax a muscle, energy comes down once again, because yes, energy is needed whenever relaxing, and it comes and it causes the calcium to leave from the actin and return back to the sarcoplasmic reticulum so it can be used once more. Meanwhile, the myosin heads go ahead and disconnect and return to its original position.
Alright, let's get back to the story now, though. So where was I? Oh yes, right after the backflip. The crowd went wild after he did that backflip, but little did he know that his worst nightmare was awaiting him in that very crowd. As he was up there, a mysterious figure watched him from the crowd, glaring with absolute jealousy. The figure then went and joined him on stage, and he was welcomed there with open arms, surprisingly. Then Drake said to him,
Harry Styles, I am so glad you're here. Are you enjoying the concert?
Yes, what an amazing concert, and I see how many adoring fans you have. Wow.
little did Drake know how jealous Harry Styles actually was of his fan base. As Drake began singing again, Harry slowly creeped up on him. Then, when he got close enough, Drake was pushed into a crowd, and later he died. Well, might as well check on his muscles again.
Once you die, your brain is no longer able to produce ATP. So, down in the muscle cells, whatever last contraction happens is what position you'll stay in. This is because there is no ATP that can come and cause the myosin heads to once again return to their position, or to cause the calcium to go from the actin back to the sarcoplasmic reticulum. This is called rigor mortis, and it normally sets in 2 to 6 hours after death. It stays like that for a number of hours, but it really depends on the temperature of the area the dead body is in.